Scientists found the universe isn't just expanding, it's accelerating. Something unknown is pushing galaxies apart. And when they realized how big this discovery was, two of them did something crazy to prove it. When I first heard about this story, I couldn't believe it. In 2017, I was an undergraduate student studying astrophysics at a university. But this discovery didn't happen in my lifetime, so I am gonna do my best to explain what happened like I am back in high school. So if I use any words that are confusing or you need anything clarified, leave a comment below. I'll get to it right away. Anyways, let's talk about dark energy. The story starts way back in the 1990s. At this point, scientists had already confirmed the universe was expanding. Everything was moving away from everything else, and it seemed like it always had been. They could tell this by looking at distant galaxies and seeing that the light was stretched out, shifted towards the red end of the spectrum. This is called redshift, and it happens because when light passes through space, it moves faster than the galaxy it's emitted from. So, if I send a photon of light towards you with a frequency of, say, 100 Hz, but the galaxy moves away from me at 10% the speed of light, then by the time that photon reaches you, you're going to see it as having a lower frequency, since it took 10% longer to arrive than it would have otherwise, which is basically saying that space has expanded 10%. It's a bit oversimplified, but that's the basic idea. The more distant the galaxy, the faster it seems to be receding. That's what we observe, but here's where things get weird. You might think that the farther a galaxy is away from us, the slower it should be receding. It would make sense if all the galaxies were attached to some sort of giant balloon, and as you look farther out into the universe, you're just seeing parts of the balloon that are farther apart. But again, this is where things get weird because there's another factor at play, one that's not gravity. Remember, gravity pulls objects towards each other, and the farther apart they are, the weaker that force becomes. So, for example, I'm being pulled towards the Earth right now. And even though the moon is farther away than I am, it's still exerting a gravitational force on me because of its mass. But if the moon was twice as massive, it would exert a larger gravitational force on me, even though it's still the same distance away. What scientists found is that the force that's repelling galaxies isn't like this. It doesn't weaken as the distance increases. If anything, it gets stronger. Okay, so maybe that's not so surprising. Maybe there's some invisible repulsive force that's causing the expansion of the universe. But wait, it gets weirder. This repulsive force is also speeding up. In other words, the universe isn't just expanding, it's accelerating. Now, this could mean a few different things, but at the time, scientists believed that maybe there was some sort of energy contained in the vacuum of space itself. You know how sometimes when you're walking down the street and you pass someone, you say hi to them. Well, sometimes they don't say hi back. Sometimes they ignore you. Well, that's kind of like empty space. Most of the time, space is empty and nothing happens. But occasionally particles pop in and out of existence, and they can interact with each other. And this is actually what we mean when we say that space has a vacuum energy. But this wasn't enough to cause the expansion of the universe. So, scientists proposed something called dark energy, and now we come to our story. In 1998, two teams of astronomers were studying distant supernovae. A supernova is the explosion of a star, and these explosions are so bright that they can be seen across the entire universe. But remember, light takes time to travel. So when we look at a supernova, we're seeing it as it was hundreds or thousands of years ago, not how it is right now. So these scientists were interested in using supernovae as a sort of standard candle to measure distances throughout the universe. Like if you know how bright a candle flame is, you can calculate how far away it is by how dim it appears to you. These particular supernovae are called High-Z Supernovae, and they're thought to occur when a white dwarf gains mass and explodes. But regardless of why they explode, scientists knew that all type E supernovae were about equally bright, so they could be used as a sort of universal measuring stick. So these two teams wanted to study distant supernovae to see if they could determine the rate of expansion of the universe. One team led by Saul Perlmutter at the Lawrence Berkeley National Laboratory focused on supernovae within 10 billion light-years of Earth, and the other team, led by Adam Rees at Johns Hopkins University, studied those farther away. Each team needed to determine how bright the supernovae appeared to us and then compare that to their intrinsic brightness to figure out how far away they were. Then they could plot the apparent brightness against distance and find the rate of expansion of the universe. For example, if the points on the graph lie on a straight line, then the universe is expanding at a constant rate. If the points lie on a curve, then the universe is accelerating. And when they analyzed their data, both teams found that the universe was accelerating. To be honest, I'm simplifying quite a bit here. There's a lot more that goes into their analysis, like how they corrected for the fact that light gets absorbed by dust in space and how they determined the redshifts of the supernovae. But ultimately, both teams came to the same conclusion. And when they realized how big this discovery was, they decided to include every member of their team on the paper and released it in a single package. I wish I could describe how big this discovery was, but honestly, it was so big that even scientists who were working on completely unrelated stuff immediately dropped everything to start studying dark energy. To put it simply, almost everything we observe in the universe can be explained by gravity. Planets move around stars, stars move around in galaxies, galaxies move around in clusters. All of this can be explained by gravity, but dark energy is different. It's a new force of nature that we don't really understand. As Carl Sagan once said, extraordinary claims require extraordinary evidence, and that's exactly what they got. But you might be wondering why I put the years 1998 in quotation marks. Well, that's because we never actually observed dark energy. We just saw that something was causing the expansion of the universe to accelerate, but we didn't know what that was. The most straightforward explanation was that it was dark energy, but it could have been something else. And in the years since, scientists have tried to pin down exactly what this is. And there are a ton of other models and explanations out there. But the observations that Perlmutter and Reis published in 1998 were so extraordinary that it caused an entire paradigm shift in cosmology. Okay, so what did they win? Well, in 2011, both Perlmutter and Reis were awarded the Nobel Prize in Physics for this discovery. To be fair, they probably wouldn't have won if it wasn't for the fourth member of the team who sadly passed away before the prize was awarded. His name was Brian Schmidt, and he was a graduate student at the time. He was the one who noticed that their data could be explained by a cosmological constant, which is essentially what we refer to as dark energy today. Now, personally, I think this is a crazy story, and it shows that science really does work. When you see news stories about scientists arguing with each other, it can be hard to remember that science really is a process that works. Just look at this case. Two groups of scientists were trying to find the same thing, and they managed to do it. The universe isn't expanding at a constant rate. It's accelerating, and we have the data to prove it. Thanks for watching. I hope you enjoyed the video. If you liked it, please hit the thumbs up button.